So this was pop quiz 2, which was related to the complete course content. You can use my chat screen annotation to answer the questions, and I expect active participation from everyone. You can use any mod. The first question: chlorine react with phosphorus to form phosphorus trichloride or phosphorus 3 chloride. The equation is exothermic. Explain in terms of the bond breaking and bond forming why the reaction is exothermic. So more energy is released in bond forming. So energy released in bond forming is more than energy absorbed. So usually it's a 2-mark question. So first thing, when you list, you will mention bond breaking is endo. The simple answer for this one. That's right. You can write different ways to answer. The simple answer you will mention bond breaking is endo, bond forming is exo. That is 1 mark. And then you will mention because the bond forming energy is more than bond breaking, then it is exothermic. So the points, simple answer, you will mention bond breaking is endo. Bond forming is exo. That is 1 mark. Then here in this example, the bond forming energy is more than bond breaking. That's why the overall energy, overall reaction is you have to mention both, because when a chemical reaction happen or occur, two things happen. One is a bond break, another one bond form. Like example here, we have a chlorine molecule. 3 chlorine molecules are there. Phosphorus is an atom, so there's no bond here. And then it will form PCl3. So 3 bonds are there between phosphorus and chlorine in each molecule. So what actually happened? First, energy is absorbed in a bond breaking. So this is reactant side is a bond breaking side. When chlorine and phosphorus form a bond, they release energy that will be exo, which is a bond forming. So always mention these first 2 points. Bond breaking is endo, bond forming is exo. That is 1 point. And because this reaction, the bond forming is more than the bond breaking, that's why the overall reaction is exothermic. So to break the bond, so any reaction happen or occur, there is always some of the energy is needed to break the bond. Some energy is released when the bonds are formed. We check which proportion is greater. If the bond breaking is greater, then we say it is endo. If the bond forming is greater, we'll say it is exo. So first point will always be same. Like the first point will always be same. The second point only if it was an endothermic reaction, then we change our answer. We'll say the bond breaking is more than bond forming in that case. When chlorine reacts with aqueous potassium iodide, a brown solution is formed. Name the products of this reaction. A chlorine is reacting with potassium iodide. So as a result, it will give potassium chloride plus iodine. When aqueous bromine is added to chlorine, there's no reaction. Why there's no reaction? Because bromine is less reactive than chlorine. Phosphorus 3 chloride react with water to form a mixture of phosphoric acid and hydrochloric acid. Construct the equation for this reaction. So PCl3 plus H2O gives H3PO3 plus HCl. Then the equation must be balanced as well. Whenever we start balancing a normal equation, we start with oxygen. followed by hydrogen, and then any other element. So first, always try to balance oxygen. How many oxygen do you see on your right hand side? 3. So how many oxygen we need here? We need 3, because oxygen on the right and the left should be same. So we start with oxygen, we put 3 is already here. No, don't start with hydrogen, start with oxygen. It will make it much more easy to balance the equation. I know you're trying to balance hydrogen first, like 3 plus 1, 4, but just start with hydrogen, start with oxygen, I mean. So when you start with oxygen, you will put 3. So oxygen is balanced for us. Now we will move on to hydrogen. 3 multiplied by 2, 6. 3 are already there. So if I put 3 here, then hydrogen will be balanced. Then chlorine 3 is already balanced and phosphorus 1 is balanced. So start with the hydrogen, the normal equation, start with hydrogen followed by, start with oxygen followed by hydrogen and then other element. But for the combustion equation, start with carbon followed by hydrogen and then at the last oxygen. That's for combustion. For combustion equation, that's how you balance. But other equations always start with oxygen, which make it much more easy to balance. Question 2, this question is about the metal and the metal compounds. Silver is a transition element. Potassium is a group 1 of the periodic table. State 2 differences in the physical properties. So you can compare the physical properties such as density. You can compare density, you can compare melting point, or you can also compare their surfaces, like hardness, you can also compare. The next is the number of the proton, that is 47. Neutron, the difference is there for 109 minus 47. And the last, because it is a positive ion, so it will have less electron, one less electron. So 46 electrons are there. Potassium react with water to form a gas which pops when a light is splint. Complete the equation. First, whenever you complete the equation, always complete the product, then the balancing part. So hydrogen will be there. Like first we complete the equation. Potassium plus water gives potassium hydroxide, and these are alkali metals. So so first we start with oxygen, which appear to be balanced both sides. Then hydrogen. So 3, if I put 2, hydrogen is 4, and I put 2, hydrogen is 4. And oxygen is also very balanced, and then potassium too, so it is balanced. When zinc carbonate is warm in a closed container in an equilibrium, a mixture is formed. The forward reaction is endothermic. Describe and explain the effect on the position of equilibrium. If it's an endothermic reaction, and we are increasing a temperature. And we are decreasing a temperature. So if we decrease the temperature, so where the equilibrium or the balance will shift, equilibrium or balance will shift towards the left hand side. So the key points, how you, when you mention this, first 1 mark is there, equilibrium move towards the left, or more product, more reactants or less product, that is 1 mark. And the second mark is decreasing a temperature, push the reaction in the direction of releasing energy, or decreasing temperature, push in the direction of exothermic, because if forward is endo, backward will be exo. So you can mention that point as well. Describe and explain the effect, if any, on the position of equilibrium when the concentration of a carbon dioxide increase. If we add more carbon dioxide, where the equilibrium will shift? So it will shift towards the left hand side, good. And why it will shift towards the left hand side? Because there will be more product or more collagen or high concentration of a product. That's right. Another, for example, this is not the question. If there was a question, if we increase the pressure, where the equilibrium will shift? This is not the question, like you don't find, but what if there was a question that we are increasing the pressure? If we increase the pressure, where the equilibrium will shift? So it will shift towards side of, no, it will shift towards side of less moles. If you see how many moles of a gas, there is no mole of a gas, zero. How many mole of a gas? Zero. And how many mole of a gas? One. So when you check reactant side, you have 0 moles of the gas, and the product side, you have 1 mole of a gas. So when you increase the pressure, equilibrium will shift towards side of less moles. So in that case, it will shift towards the left-hand side. But remember one thing, don't count. Some student count the moles of solid and liquid as well. You don't have to count. You just have to see the moles of the gas. What if, for example, this equation, example, it was written 2 here. Now where the equilibrium will shift? If I increase the pressure, that will also shift toward the left-hand side. Because when we check the moles in pressure, we don't bother about the solid, liquid, or aqueous. So even it is solid 2 moles, but we consider 0 moles of the gas. 0 mole and 1 mole here. So even if you increase pressure, in that case also the equilibrium will shift toward the left-hand side. So whenever we change the pressure, equilibrium will always shift towards the side where less moles of a gas are present. So you have to see the equation and as well as the state symbols when if the question was what is the effect of changing pressure. This question is about angelic acid is shown. State how the structure shows that it's an unsaturated because there's a carbon-carbon double bond present. That shows it is an unsaturated. Deduce a molecular formula. Molecular formula, you just have to count the atom of each and write. Some student I observe when they ask for molecular formula, they write in this manner. C3H9OH. That's wrong. Because you're not supposed to write a molecular formula in this manner. You have to show atoms of each individual element. Total. So 1, 2, 3, 4, 5 carbon, 3, 6, 7, 8 hydrogen, and 2 oxygen. Then it is a weak acid. Define the term weak acid. So the term acid means proton donors and term weak means it's ionized partially. Its acid can be polymerized. State the type of polymerization occur. So it will be addition, not condensation. How we identify its addition, not condensation. You have to see the structure first. The condensation polymer can happen, as I mentioned, if we have amine group and carboxylic group. If we have carboxylic group and alcohol group, and if we have alcohol group and alcohol group. These are the combination which can lead to the condensation polymer. If you see a molecule, there is a carboxylic group. Okay. Carboxylic is there, but we don't find amine or alcohol in this. So means it cannot undergo a condensation polymer. Yeah, amino acids actually contain amine and acid group. So that's why I'm saying these are the combination which can lead to a condensation polymer. So there is acid group, but there's no amine group or alcohol group. It means it cannot undergo addition. It cannot undergo condensation. So then for addition, what is the condition for addition? Alkene should be there, as you can see, a double bond. So whenever you see a double bond, it will make an addition polymer. What if this was the structure like, what if this was a structure like NH2? Now which polymer it can form? It can form addition because of this, and it can also form condensation because of acid and amine group. So, but this is only acid was there, no amine group or alcohol. That's why it is only addition polymer it can form. Then we have to draw the structure of the polymer, 2 repeat units. So you will draw the structure in the same manner, but without a double bond. And 2 repeat units means we have to draw this twice. When they ask for the repeat units, you are not supposed to put a bracket and write n, just link them together, but don't put a bracket and write n. Because if they ask draw polymer, then it should be bracket and n. If the repeat units means a part of the structure, then no need for the bracket or n. This is enough. Then it is reacting with methanol to form an ester. This complete the structure. Look, I will show them the molecule. Like this is an acid, and they mention it is reacting with methanol, CH3OH. So what will happen? What will be the product? It will form an ester. So this carbon chain will take position of H. And that will be the ester. So this carbon chain is there till here. So C double bonded with O and O is there. Like C double bonded with O and OH. This was the original structure. But when it react with methanol, like this is a reactant, methanol CH3OH. So this carbon chain will take position of the hydrogen, and we have to show all the bonds and all the atoms. So this will be carbon, and then it will have 3 hydrogen. And then H when OH, it will form a water as a product. And this reaction can happen or occur in the presence of sulfuric acid as a catalyst. In part F, construct equation for combustion of methanol. We were burning methanol. C2H5OH, we want, sorry, C3H, CH3OH. Sorry, it is methanol. So CH3OH we were burning. It gives carbon dioxide plus water. And then for balancing, you start with carbon, followed by hydrogen, and then any other element. So we start with carbon. You see one carbon, carbon is balanced. Because CH3OH plus O2 gives CO2 plus H2O. So carbon is already balanced. What about hydrogen? 3 plus 1 makes 4. So we put 2, hydrogen is balanced. And then oxygen, 2 plus 2 makes 4. So we want 1 is already there. I need 3 here. So what it will be? It will be 3 by 2. If you write 3 by 2, that is also fine. Or you can multiply the whole equation by 2. So first, because 1 oxygen is already there. So we have CH3OH plus O2. As a result, it was giving CO2 plus H2O. So for balancing, we start with carbon for combustion equation, followed by hydrogen and then oxygen. 1, 1 and 4, so we put 2. And then oxygen 2, we have 4, we have 1 plus here 3 and there. So 1 is already there. So here we need 3. So I can say 3 by 2. This is right. You will score the mark if you write a fraction. Or if you want to convert into a whole number, just multiply this whole equation by 2. So this will be 2. This will be 3 by 2 multiplied by 2 will be 3. This will be 2 as well. And this will be multiplied, turn into 4. So this is the equation. Like 3 moles or 2 moles of methanol react with 2 moles of methanol react with 3 moles of oxygen to gives 2 moles of carbon dioxide and 4 moles of water molecules. So both ways are correct. The fraction is acceptable if you write 3 by 2 O2, that's correct. Or you can just convert into a whole number by multiplying all of them by 2. The next is, this question is about ammonia and nitrates. What is the source of hydrogen? Natural gas, methane, okay. Cracking of a hydrocarbon, you can also mention methane, okay, that's fine. And here, methane and steam. Methane plus steam will result in a formation, and then nitrogen you can get from air. The next question is related to the moles. A student adds 4.5 grams of a sodium hydroxide to 50 cm cube of 1.25 mole per dm cube ammonium sulfate. By calculation, show ammonium sulfate is an axis. Look, first thing I explained to you, whenever you're finding the like a limiting or excess reagent, first find the moles of both reagent. So first what we'll do, we'll find the moles of ammonium sulfate. How to work out the moles of ammonium sulfate? Moles equal mass in gram over molar mass. So mass in gram is 4. For oh, sorry, yeah, right. Ammonium sulfate, we have the volume and concentration, that's right. So we multiply that. For sodium hydroxide, the mass is given, so we'll use that. So concentration is 1.25 multiplied by 50 divided by 1000. What is the answer for this? How many moles are there for ammonium sulfate? 0.0625. Then we work out the moles of sodium hydroxide, which is mass in gram over molar mass. So mass in gram is 4.5 and the molar mass, you have to use a periodic table. But molar mass, don't use the equation like here, 2 moles are there, but molar mass is always mass of 1 mole. So sodium hydroxide, sodium is 23, oxygen is 16 and hydrogen is 1. So total will be 40. How many moles we get? 0.1125. Okay. Now we take a ratio. We take a simplest ratio between them, ammonium sulfate moles and sodium hydroxide moles. Like this is 0.0625 and this is 0.1125. We divide by the smallest value, like 0.0625 and 0.0625. So this will be 1 moles and this will be 1.8. Okay. So the ratio of the mole is 1 is to 1.8. But according to equation, 1 mole required 2. But according to our calculations, for 1 mole of ammonium sulfate, we have only 1.8 moles of sodium hydroxide. So means sodium hydroxide is the limiting. So ammonium sulfate is an excess. So how you'll score the mark? 1 mark you'll get the moles for ammonium sulfate. 1 mark you'll get the moles of sodium hydroxide. Then take the mole ratio and compare with the equation. According to equation, 1 need 2. But according to our value, 1 is 1.8. So we have less sodium hydroxide. So sodium hydroxide is a limiting, or ammonium sulfate is an excess. Is it clear? Discussion? Okay. When a dilute, why ammonium sulfate in excess? Why not? Yeah, look, why ammonium sulfate is in excess? Why not sodium hydroxide? If you see the equation, according to equation, 1 mole need 2 for a complete reaction. But according to our calculation, when we calculate the ammonium sulfate to sodium hydroxide ratio of the moles, 1 mole is reacting with 1.8. But for a complete reaction, how many we need? We need 2. But we don't have 2. We have less. Like for a complete reaction, there should be 2 moles of sodium hydroxide. But we don't have 2. We have only 1.8. So we have less sodium hydroxide than what we need. We need 2, but we have only 1.8. That is why sodium hydroxide is a limiting factor and ammonium sulfate is an excess. In part C, when a dilute sodium hydroxide is electrolyzed, the hydroxide ions are converted into oxygen and water. At anode, construct ionic equation for the reaction that take place at anode. What is the equation for a hydroxide ion? Discharge of hydroxide ion. So when 4 hydroxide ions are there, they will give O2 plus 2H2O plus 4E. Don't forget to put a negative sign on electron. Don't write just E, write 4E, negative. The first stage in the test for nitrate ion is to heat aluminium and sodium hydroxide with a solution contain nitrate ion. State the type of a chemical reaction occur when the solution containing nitrate ion is heated with aluminium and sodium hydroxide. What kind of reaction happen or occur? Yeah, redox reaction or reduction is thermal decomposition. No, decomposition is when one reactant produce more product, but we have like the decomposition is when one reactant produce more product. That is called a decomposition reaction. So we cannot say decomposition. Same thing. Why we cannot say a precipitate here? The test for nitrate ion does not give any precipitate. So it's not a precipitate. It's actually a reduction reaction here. Yeah, redox reaction. That's right. If the initial reaction is a redox reaction or simple reduction reaction happen initial. You can also say redox or reduction. Reduction is more appropriate as compared to only because in a redox both oxidation and reduction both should happen. But here the initial reaction is a reduction reaction. Why it is a reduction reaction? Look, if you remember what happened when ammonium, like when we are testing a nitrate ion, what is the valency of a nitrogen in the nitrate ion? What is the valency? Valency means the not the nitrate valency, I mean the nitrogen oxidation number. So each oxygen is -2, so 3 oxygen will be -6. So nitrate or nitrogen is +5. And when it releases ammonia, ammonia is NH3. Because if you remember, when we test a nitrate ion, adding sodium hydroxide and aluminum powder in heat, then it gives off ammonia gas. What is the oxidation number of a nitrogen here? Each hydrogen is +1, so 3 will be +3. So nitrogen will be -3 or 3 minus individual. When we check individual level, -3 and total this. So +5 changes to -3. If +5 changes to -3, what is this reaction? This reaction is a reduction reaction. Like the nitrogen oxidation number has been decreased. That's why we call this as a reduction reaction. Is it clear, this one? How we identify First, we have the nitrate ion. Okay. Now, because the net charge on this nitrate ion, each oxygen is -2, so 3 oxygen will be -6. And for a nitrogen, because the total net charge is -1, so what should be the nitrogen? It should be +5. So oxidation numbers for the non-metals can be positive, can be negative as well. You, like, for example, if a group 1, group 2, group 3, group 4, group 5, 6, 7. So group 1 is +1, +2, +3. Group 4 is -4, or it can be +4 as well. Group 5 is -3, or it can be +5. Group 6 is -2, or it can be +6. It's not like -2 or +6. It can have any oxidation number from -2 to +6. And group 7 can have -1 to +7. That is why, like example, if I write sulfate, SO4, with a charge -2, what is the each oxygen? The one which is more electronegative is -1. So oxygen is more electronegative. As we move across the period, the tendency to attract electron increases. So they will have more negative charge. So oxygen is, each oxygen is -2. So 4 oxygen will be -8. So what should be the oxidation number of sulfur in sulfate? What should be the oxidation number? So it should be +6. So it means that even a non-metal can have positive oxidation numbers. So sulfate ion in SO4 with a charge -2, it is +6. So what actually happened when this nitrate ion convert into ammonia? Hydrogen is on the, and like on the group 1 side, and nitrogen is group 5. So hydrogen each is +1, so 3 will be +3, and nitrogen should be minus. So in a nitrate ion, the nitrogen was +5 and it is -3, so +5 turned into -3. That's why this reaction is a reduction reaction, neither decomposition nor precipitation. Is it clear, this one? So the table shows the element of group 7, group 4. Predict the density of tin. So generally you see a density is increasing here. Describe a general trend in the boiling point of a group 4 element. It's just a prediction, any number, 8.34 you're saying. So it's just a prediction, any number you can mention from a lower limit to upper limit. So what happened generally decreases, that's good. Predict the state of a silicon at 1600. The melting point of silicon is 14 and boiling point. So where the 1600 will be? Where the temperature 1600 be? Look, the state of a substance after the boiling point, it is a gas. Between the boiling point and melting point and boiling point, it is liquid. And before the melting point, it is solid. So this is a silicon and we want to find at 1600. So where is the 1600 will come? 1600 will come in this range between the melting and the boiling point. So the 1600 is between the melting and the boiling point. So what should be the state here? Then state should be liquid, because the temperature is between the melting and boiling point. If I say what will be the state of tin at 70 degrees, what will the state of the tin at 70? So it will be solid. Why? Because the solid 70 will be here, because this is 232, this is 2260, so 70 will be here. So this will be solid. If I say what is the state at 400, then it will be liquid. What is the state at 3000? It will be a gas. So temperature after the boiling point, gas. Between the melting and boiling, it's a liquid. And before the melting, it is solid. The structure of two compounds, silicon P and Q are shown. Dots are representing the oxygen, and circles are representing silicon, and the shaded circles are representing, the spheres are representing chlorine. Explain in terms of structure and bonding how, why compound P has a high melting point than Q. First, what kind of bond they will have? Both of them. So both of them will have a covalent bond because these are non-metals. And how the structures are different? So one is actually a simple, another one is a giant. Giant macromolecular, don't use the structure term. Yeah, that one is a simple molecular and another one is a giant molecular structure. And we need a greater amount of force or energy to to break all the bonds. Then dot and cross diagram for compound Q. So it is P and silicon with 4 chlorine. So silicon with 4 chlorine. Then a compound of carbon, hydrogen, silicon has a formula of SiCH3 in a bracket 4, percentage by mass of a carbon. So what is the percentage of a carbon, mass of a carbon in the compound? Dot and cross diagram we have to do. No, dot and a cross. If you want to make a circle, that's also fine. You can draw the circle around. So what is the mass of a carbon? It will be C12 multiplied by 4 divided by total mass of a compound. So silicon is 28 plus carbon 12 multiplied by 4 plus hydrogen 3 multiplied by 4, 12. So 12 into 1 and then into 100. So when you multiply, you'll get the percentage composition of this compound, which is about 54.5%. So this was a pop quiz 2, which was related to the complete course. Any question or a doubt you have related to the session? You can send your doubts on the group anytime. And all the group is open for response. You can also send your questions as well as other, if you know the answers, you can just answer the other questions from different students. And I appreciate those who are actively participating. Any question or doubt related to the session today?